So the next one says sine of 120. I'm going to draw that 120 degree angle. That goes in the second quadrant, and we can see that 180 minus 120 equals 60. So that's the reference angle. I should have said this first, but we know that sine is positive in the second quadrant. So sine of 120 is equal to the positive sine of 60, or just the plain sine of 60. You don't need to write the positive sign, but that's the idea. So we know the sine of 60 from our table is radical 3 over 2. And as I said, we don't really write plus, but it's the idea that I've decided it is positive, not negative. On the other hand, if I do cosine of 120, part of it's going to be the same, but not all of it. So here's my second quadrant angle. My reference angle is once again 60 degrees. But now since we're in quadrant 2, cosine is negative. So this is going to equal the negative cosine of 60. We know the cosine of 60 is 1/2, so this is going to be negative 1/2. The next one, the tangent of 210. We know 210 is in the third quadrant. 210 minus 180 equals 30. So this is a 30 degree angle here. Tangent is positive in the third quadrant. So this is going to be the positive tangent of 30. We know the tangent of 30 is radical 3 over 3, and it's going to stay positive. Lastly, we have the cosine of 330. We are in the fourth quadrant. We know to get the reference angle, we need to subtract from 360 there. We're trying to get to the x-axis now nearest to the fourth quadrant. So that's 30 again. This is the fourth quadrant where we know cosine is positive. So this is the positive cosine of 30, and the cosine of 30 is radical 3 over 2. So you'll see with each of these, really it's just that process of we're at an angle that's not acute, right? It's a bigger angle in the second, third, or fourth quadrant. But since it has a reference angle that's a special angle, we can just kind of break it down to the reference angle, decide if we need a positive or negative sign, and then use that chart to find the value. So we have a couple more of these, and then we're just going to kind of like add a little bit of difficulty and see what different types of problems we can do. So for this one, we are in the second quadrant at 135. Okay. We know tangent is negative in the second quadrant, so we have the negative tangent. And the reference angle for 135, we can remember it. We can do 180 minus 135, and we get that that is 45. So this is the negative tangent of 45. So this answer is -1. At any point, as long as you make sure your calculator is in degree mode or radian mode, these would have all been degree because we've been working with degrees for the angles. You could type these questions in your calculator. Now that one will just give you -1. But even with the radicals, you can type it in, make sure your sign is correct, positive or negative, and then make sure the decimal matches up with whatever. For example, if you get radical 3 over 2, you should get that 0.866 and so on, if that's what you think the answer is. Last one in this section, now we're at 330. On a different problem, we already found that the reference angle is 30 for that. This is the fourth quadrant where sine is negative. So now we have the negative sine of 30. So -1/2 for that one. Now we're just going to do ones with radians. Now there's really two ways to do radians. Maybe you have the radian measures memorized from the unit circle, but there also is a way to convert from radians to degrees. We've kind of stayed away from that just because we really want you to get the idea of pi over 6 is 30 and just kind of know those conversions without doing a process for them. But here I'm just going to show it with this one. I think we know pi over 6 is 30, but if you want to convert that to degrees, you can multiply by 180 over pi. we know 180 degrees is equal to pi radians. So the way I would explain it is that we're going to degrees. We want to take out the pi and put in the degree measure of the 180. So this is 180 divided by 6. So that is going to be 30 degrees. So if you don't know it, you can convert it. You can also just think about things in radians. The tangent of 30 is radical 3 over 3. Now, I do think you know that pi over 6 is 30 degrees, but you might not remember what 3 pi over 4 is, like the next one. So the first thing I'm going to do is just convert that. And the pi's always cancel here as long as there's a pi in the initial angle. You can do 3/4 of 180 in your calculator. That is 135 degrees. So in this problem, we are talking about the cosine of 135. Now we're in a different quadrant than the first quadrant, so we have to do just like the section before. Here's 135. We find our reference angle. Our reference angle is 45. 180 minus 135. Also, remember from that denominator of 4, we should be clued in to the fact that the reference angle is going to be 45. We know those radian measures with pi over 4 have to do with 45 being the reference angle. I am in the second quadrant, so cosine is negative. So I have the negative cosine of 45 degrees, which is negative radical 2 over 2. So you can see when I have to think about radians to degrees and what sign do I need, positive or negative, and then what's the reference angle. There are a lot of little steps here, okay, but it's still just one step up now that we're working with radians. So I would, if you're able to do this, that's great. When I look at 5 pi over 6, I know that's going to have a reference angle of 30 because of that denominator of 6. That's smaller than 1. 5/6 is smaller than 1, so I know I'm going into the second quadrant. 180 minus 30 is 150. Okay? Now, if you need to, I'll just quickly show the conversion. But I do want to point out that it's great if you can just kind of reason that out in your head. So this is 150 if I did 5/6 times 180. So this is second quadrant. Okay. Our reference angle here, 180 minus 150 is 30. And we know that in quadrant 2, sine is positive. So I'm just going to write that down, that step where I figured out that 5 pi over 6 is 150. And then we just said the reference angle is 30. I'm going to switch colors because it's getting crowded. So this equals the sine of 30, positive, because sine is positive in the second quadrant. And the sine of 30 is 1/2. The next one, I'm going to do even one step up. 7 pi over 4. 7 over 4, we know the reference angle is going to be 45, okay, or pi over 4. We could also think in radians. 7 over 4, that's almost 8 over 4, which is 2 pi. So I know I'm in the fourth quadrant. So this is going to be tangent. We said we know it's going to be 45 for the reference angle. And it's negative because we're in the fourth quadrant. So negative tangent of 45 would be negative 1. So that was almost with no work shown. But the point is we want to draw the pictures. We want to make sure we're sure, you know, of where we are. But ultimately, there is a point that comes that probably won't be this year for most people, but you can do some of this stuff in your head. So let's move down the page. Now this is something new. And it leads into the next lesson as well. Let me just straighten this out a little bit. That's a little bit better. Okay. So here we've kind of talked about just going around the circle once, but you can actually take an angle and go around the circle as many times as you want and then end an angle. Now, even though we go around the circle once, twice, multiple times, this angle is really just the same as this angle where I started to go around less than once. So this idea of having angles, if you go around the circle more than once, this is called a coterminal angle. So that extra time around doesn't really change anything. It has the same ending side or coterminal side with the other angle. So if I see an angle that's not in the range of 0 to 360, okay? I just add or subtract 360 as many times as I need to get it back to something I can work with. So 390 is an example. 390 means that I went around the circle more than once. It's bigger than 360, so I just subtract 360 to get 30. Now the nice thing about coterminal angles, right, they have the same exact triangle. It's in the same quadrant here. This is not for my 30, but I don't even have to think about negatives or positive. I'm just in the quadrant I'm in. So over here, we'll just draw this again for the 30. I'm going to erase the one over here because that was just my starter example. So this is where 390 is, around the circle once and a little bit more. And it is just really the same thing as 30. Other than being a bigger number, here's my 30-degree angle. So I'm doing sine of 30, right? It's in the first quadrant. Don't have to think about positive or negative, which is 1/2. So the next one shows an angle of -120. That means I went in the counterclockwise direction. That angle is somewhere around here. So what I'm going to do is I'm going to go back around in the positive direction and see where I end up. So I'm going to add 360 this time to bring it to a positive angle. So this is just practically speaking, I want to get an angle between 0 and 360. So this time I had to add. That's 240. So this equals the cosine of 240. Now we're in that quadrant. We said this is coterminal with 240. We just need a reference angle now. So 240 minus 180 is 60. We are in quadrant 3 where cosine is negative. So this is the negative cosine of 60. So we know cosine of 60 is 1/2. So we are at -1/2. The next one got really wild because we're going to have to subtract 360 2 times, right? Because it's more than 720 would be double 360. So if I subtract here, I am going to get 480. And then I'm going to have to subtract 360 again. And I get that 120. Okay, so drawing a picture of what this would look like once, twice, starting on a third time, around to 120 degrees. Okay, that's what an 840 would look like. So my reference angle, we're just thinking about the 120, so this equals the tangent of 120. We are in quadrant 2. The reference angle is 60, right? 180 minus 120. Tangent is negative in quadrant 2, so I get the negative tangent of 60. Tangent of 60 is radical 3, so I get negative radical 3. Negative 405 is also backwards more than once, so I'm going to add 360, and that's going to give me negative 45, and then I'm going to add 360 again, and that is going to give me 315. So this is equal to the cosine of 315. I'm just going to draw that large angle again, large negative angle. So I went around backwards once and then a little bit further. So that's here, which we know is really at 315. The reference angle for 315, 360 minus 315 is 45. Cosine is positive in the fourth quadrant. So I have the positive cosine of 45, which is radical 2 over 2.